Double angle identities, part 6, further examples. So example 11, we have to show that the left hand side is equal to the right hand side. We do have a double angle relationship. You've got half A and you've got angle A. Starting with the numerator here, so we've got sine, the double angle formula for sine. Sine 2A is 2 sine A cos A, and modifying the angles. So if you take an angle on the right hand side, the angle A gives you 2A, so half A. If you double it, you get angle A. So I'm going to replace the numerator with this. Now for the denominator, the cos A, ideally I want to end up with a fraction that's got sine over cos to give tan, and for the angles in my fraction here to be half A. So double angle formula for cosine, again modifying the angles to fit the ones which we have in the problem here. So now we can replace cos A here, cos A, with this. Okay, so that gives us this fraction, and that 1 and that minus 1 will cancel, that 2 will cancel with that 2, and then we can cancel a cosine half A with a cosine half A here. That's a squared one, so it's something from the top with something from the bottom will cancel. So I'm doing this, that square has gone, simplifying, same angle, sine over cos is tan, and that's what we were trying to show from the beginning. Example 12, once again we have a double angle relationship. We have x and we have 2x. Okay, so I've written the left hand side term, so cosec is 1 over sine, and cot is cos over sine. There. We're adding the fractions, we have the same common denominator, so we now have a single fraction. If we add them together, we need to use the double angle identities next, because we have x and we've got 2x. Okay, so I've used, for cos 2x, I've used an identity that will just give me cosine, so no sine terms, because cot will be cos over sine, so I want cos in the numerator. And for the denominator, there's only one identity for sine 2x. I've used that, 2 sine x cos x. If I remove the brackets and simplify, the 1 and the minus 1 will cancel. It gives this, and a cosine term from the top will cancel with 1 from the bottom. Now we just, and the 2's cancel, we've got cos over sine, and cos over sine is cot x. Example 13, we have to show that the right hand side simplifies to tan x, so I'm going to work on the right hand side. Ideally I want a sine squared inside the third, but in the numerator I want a sine squared over cos squared. A sine squared over cos squared with the square root will give a sine over cos, which will give the tan. That's what my aim is. Okay, so using double angle identities, because we have angle 2x, we have angle x, it's telling you to use double angle. So I've written my cos 2x term in terms of just sine terms. So have a look at the double angle identities for cos, and you'll see why I've chosen this one, because it's only got sine in there. And for the denominator here, I'm going to use this identity, which is only in terms of cos. And then we simplify. 2's will cancel, sine squared over cos squared is tan squared, you square root the tan squared, and you get tan, which is what we were trying to show.